morning, ProStart family, and to those of us who are not ProStart, welcome. We are so excited to have you this morning for our webinar with NASA. How exciting. And I know you guys don't want to hear from me, so I'm going to immediately kick it right over to Jackie so we can get this thing started. Jackie.
Well, thanks, Jen, and a big welcome to everyone tuning in today from Massachusetts and all across the galaxy to learn more about how NASA designs food for the astronauts. Now, more than ever, it's important for culinarians to connect, to share, and to offer inspiration, which is exactly why we're so excited to be here today just for you, the future leaders of the food service industry. Before we begin, as a note, we will be taking questions from you, the viewers, as we are able. Please use the chat function to collaborate with other viewers and the Q&A function to pose questions to our special guests from NASA. So let's try out the chat. Please feel free to let us know where you're tuning in from. I'm Jackie Pressinger, Director of Strategic Partnerships for American Culinary Federation. I'm honored to introduce a special guest today. Ashton Garrett is our ACF Young Chefs Club president, and he is a very talented culinarian. He is also our USA ambassador to the World Association of Chef Societies. He is a graduate of Johnson & Wales University's bachelor's program. He's a winner of Guy's Grocery Games. I can go on and on. I'm just so proud of this young culinarian. And at this point, I'd love to pass it over to Ashton. So thank you very much for being here.
Jackie, thank you so much. Welcome everyone to this special presentation. I'm very excited about this presentation. I think it's going to be amazing. As Jackie mentioned, my name is Ashton Garrett. I am the ACF Young Chefs Club National President, as well as the WAX Global Ambassador for the United States of America. Today, we'll be taking a virtual trip to space with our featured speaker today. I'm overjoyed to welcome Miss Allison Westover. She is the NASA project engineer and the HUNCH Culinary Challenge program manager. So I'm deeply excited and very honored for her to join us today. At this time, I'd love to turn it over to Miss Allison for this wonderful presentation. How are you, Allison?
I'm good. Thank you very much.
Absolutely.
I'm excited to be here today.
Wonderful. We're overjoyed to have you. Thank you for spending some time with us and bringing us into the inside of NASA and how you are able to, create meals for astronauts and just the entire program. So without further ado, I'd just love to turn it over to you.
Great, thank you. So I work out at the Johnson Space Center in Houston, Texas, and I am a biomedical engineer by trade and have been at the Space Center for about 20 years now. I work in this program with the Johnson Space Center Food Lab. And so we've developed a neat program that we have students from all over the country that are participating in. So I'm very excited to share with you some of the concepts and aspects of food science and microgravity and the way it affects food for the astronauts. So I'm going to start my presentation, and I will tell you there are some firewalls that NASA has, so some of this presentation might be a little jumpy, but it's just part of us being in this kind of virtual world right now. So I'm going to share my screen. Okay. Okay, so I'm going to be talking about the microgravity effects in food processing. And why do we need to worry about food?
Allison, this is Matt. I apologize for interrupting. I don't think your share screen went through all the way.
Okay, let me try that again. Okay, share screen. Okay, let's try this again.
There we go. Thank you.
Thank you. Okay, so talking about microgravity and its effects. So one of the biggest things that comes up and people ask all the time, why is food so important for astronauts in space? And of course, all of us down here on Earth, we all want to try to eat all our greens and have some good nutrition, but there's some really special reasons why it's so important for them. When an astronaut gets up in space, there are a lot of physiological changes that happen. and it can really affect how they are in space health-wise. So for example, their GI system slows down a lot. Our gravity actually helps with our little sensors in our GI system that tell us that it needs to keep moving. And when you're up in space, it kind of just doesn't really have that, so it slows down. Our vestibular system gets really confused, which basically means that the little hairs on the inside of our ears that tell us that we are, standing up or laying down, they don't have any of that. It gets very confused. And so up in space, there is no up or down. So that is a really big problem for them. There's a big fluid shift that initially happens. All of the fluid wants to move up into their chest. And it happens that it'll start enlarging their heart and they'll get the puffy face. And so when they enlarge the heart, then the body naturally wants to become it wants to get rid of all this extra fluid. So for the first couple of days, they get rid of the extra fluid. Hematological, the shape of the red blood cells, it actually changes from a normal discoid shape, which is actually the perfect shape for the best way to transfer oxygen to our body, and it kind of puffs out and becomes a sphere. So we're not getting as much oxygen as we'd like. And then immunologic, there's a lot of changes that'll happen. So a lot of the vitamins and minerals we can't process as well. So how does nutrition help with this? So nutrition helps a lot because if we have more fiber, we're going to help our GI system. We definitely, because of the fluid shift, we don't want to have too much sodium, because if we have too much sodium, then they're going to start getting unnecessary edema or kind of fluid pockets in their body. So we want to make sure that we have less sodium for them. Also, we want to increase the amount of bioavailable vitamins that can help their immunologic system. And a lot of that we want to have not just in a pill form, but we want to have in the food. We want to have limited saturated and unsaturated fat because of the fact that their heart is working so much harder up in space because it's having to pump all the blood down past the microgravity effects down to feet and fingers. We want to make sure we have a lot of good iron in our food because of the oxygen needs that change because of the shape of the red blood cells. And then these astronauts, they have to do 2 hours of physical exercise a day. And that is basically so that they are helping their muscles and their bones so that they don't lose that, because if they're not doing that, they're going to lose it. So we have to make sure that they have a really good caloric intake. Okay. The other odd thing that'll happen too is with that fluid shift and how it makes their faces puffy, they actually have a lot of trouble with taste and smell. It's kind of like they have a constant cold, even though they're not feeling sick. They just can't taste and smell as well. So now we're going to go into a video.
There's no refrigerator on the International Space Station. The food all has to be shelf stable at room temperature. And the reason there's no refrigeration is because there's limited resources on the International Space Station. And this is also going to be true on a mission to Mars. Keeping foods stable for 5 years is a difficult challenge because you have to stabilize the nutrition and you have to stabilize the quality of the food, so how well it tastes. So if you've ever had a food that's been in your pantry for a certain amount of time and it's past the best of use by, but it's something like a granola bar and you still try it, or you have some crackers in there and you try them and you're like, oh, these aren't very good, chances are that food's still not 5 years old. So when we go to Mars, the food actually might get sent ahead of the crew. On the International Space Station, they get resupply missions every few months. On a Mars mission, they probably won't have any resupply. The astronauts are really excited when fresh fruit comes up on resupply missions because they don't get it very often, only when a resupply mission docks.
NASA cares a great deal about food for the astronauts. They need to consume enough calories, enough nutrients to stay healthy for the whole mission. And so a mission to Mars is particularly challenging. It could be 30 months, 6 months there, 18 months stay, 6 months back. And the food system might be deployed in advance of the astronaut. We may need food that will last 5 years and be delicious in the 5th year.
Flavor includes taste, which is things like salty and bitter and sour and sweet, and umami, which is actually savory. And it's also a lot of what you get when you're smelling the food. So most of flavor is aroma. When you're looking at taste changes, there's a lot of things that are going on in orbit that could be contributing to a sensation of a taste change. So potentially it could be the fluid shift in the body, so you don't taste things as well because you have a sensation that you have a cold. The aromas don't dissipate the same. They don't rise like they do here on Earth without gravity, and so they dissipate instead of rising, and so they're not getting that aroma, which is most of flavor. The astronauts have about 200 different food options, and that includes their beverages. It's cooked and prepared here on Earth. We remove the water. When they add it back, it's real food. This actually will taste just like you would expect a pasta with shrimp product to taste when you add water back. The reason we remove the water is partially for mass saving. So when you send this up into orbit, it weighs a lot less, and it costs a lot to launch a kilogram into space. So they recycle a lot of their water on the International Space Station so they can add the water back. And we expect that that will continue as they go on Mars missions, that they'd still be recycling a lot of their water. We know from studies that only about 7 of 65 of these that are currently in our food system would still taste good after 5 years. So this is like canned food that you buy in the grocery store, except in a flexible, lightweight pouch. If we do send these to Mars, we have to have a countermeasure in place, which could be a new technology to produce them. So we're still looking into different technologies and how much extra shelf life we can get. Can we get to 5 years by using those technologies or even combinations of them?
Okay, so you learned about different kinds of food technologies and how that's so important for us. And so that gets us into food science. So a lot of what NASA does is concerning itself with the food science aspect. And so for food science, it's the study of all the physical and biological and chemical processes that are taking place that would affect food deterioration. And so we always are looking at different ways that we can do food processing and potentially some food engineering. And so when we have food scientists that work at our Johnson Space Center Food Lab, we also have technologists, and they are there using their skills from chemistry, engineering, microbiology, and nutrition to help them improve the safety, the nutrition, the wholesomeness, and the availability of the food, including bioavailability. And some of these food scientists have different specializations that work over at NASA. And so some of them are worried more about the processing, some are about the preservation of the food and how long it can last shelf stable. We also have individuals that look at the packaging. And so we also have to make sure that everything meets the government specifications and regulations, of course, for any of our food that is made. Food technology. So that is going to be looking at the application of the food science for this processing and packaging and distribution. And so there's a lot of fields that relate to this. So we have people that work over there with our food lab, and they might have a background in chemistry or biotechnology or engineering, quality control, even from a safety standpoint, and so that management. So there's a lot of different kinds of people that work on our food and nutrition for the NASA Space Center. So one of the things that we want to do whenever we're sending food up, okay, so we have several different kinds of ways that we can send our food up. So we can vacuum seal it, okay, and that might be just some natural food like a granola bar, some M&Ms or cookies, and we just are taking the air out of it. We have thermostabilization, and you saw that in the video, and she was saying that it's like a canned food item that you might find at the grocery store. It's kind of like an MRE for anybody that's familiar with that from the military. Then we freeze dry our food as well, which means that we have to add some moisture back later whenever they get up to space. And our food, some of it needs to be irradiated, meaning it needs to help take away any of the bacterial aspects. So when we're vacuum sealing, we're only just removing the air. And so we're just trying to keep it from oxidizing and that process from happening, which would reduce the viability of it if we just send it up like it was. Most of it can last about 2 years. And so that is what our vacuum seal is doing. Thermostabilized. Okay, so when we're doing that, what we're doing is we're increasing the heat to an extreme amount and then putting it and sealing it inside of the bag. And so we are removing harmful bacteria and enzymes that would contribute to the food spoilage. So it doesn't take up any kind of extra water. We don't add anything extra in there. So when you're thinking about this, it might be like salad or a stew, some different kinds of desserts that might have some of that, natural moisture in it. So we leave the moisture in the thermostabilized. Freeze drying, that is when we are completely removing all of the moisture out. And the biggest reason that we started doing this was because we wanted to be able to save on the weight that we were going to be sending up, because every bit of weight costs a lot of money to be able to launch it, because the heavier that something is, the more propulsion that we have to be able to send it up and to get past the bounds of our gravity. So we want to make sure that it's as lightweight as possible. So we remove everything and then we check it for bacteria. We have to make sure, and then we can also irradiate it prior to the packaging so that we're making sure that we're removing any kind of bacteria or anything else that would be harmful. We have to get the moisture out. We put it in a negative 40-degree chamber, and it has a drying process. And so we know it's complete because we have moisture sensors, which we have developed all of this with our food technology systems. And so we use a vacuum pump that is actually taking the air out as well. So we're removing the air and the moisture from this. Okay, and so now we're going to go to another few videos. Let's stop sharing.
Hi, now we're back here inside the Space Food Laboratory here at the NASA Johnson Space Center. And again, earlier we've been talking about some of the preparation and talking about food and some of the menu items that the crew aboard the International Space Station will be having this Thanksgiving. And again, we are here with Vicki Claris, our NASA food scientist. Tell me, this is just another area of that food lab, so tell me exactly what area are we in right now?
Okay, what you see behind you is our packaging room. And so it's really a commercial portable clean room that we've converted into a packaging area. So all our packaging equipment is inside. It has HEPA filters that filter the air to help keep the contamination possibilities down when we're packaging food. And so the type of food that we do all our beverages would be packaged here, like we have in this package, okay. And all our freeze-dried items, as well as our bite-sized products like M&Ms, cookies, crackers, candies, all of those items would be packaged in the equipment that you see here in this facility.
Okay, great. And so tell me a little about the packaging. What do we have? What kind of packaging is this?
The beverage package, all of our beverages are in powdered form. And so this is a foil laminate pouch that we buy from a commercial manufacturer. We buy it, it's sealed on 3 sides, it's open on this end. We weigh in the appropriate amount of powder for a single serving. And then the packaging equipment that you see here is designed to seal the beverage adapter or the septum adapter assembly into the end of the package. And so this is what allows the water to be injected on orbit using the rehydration station. Inside this is a septum, and the septum is a little plastic valve. So the needle inserts and the water is injected, And then when the needle is withdrawn, the septum closes off to prevent the fluid from flowing out of the package.
Okay, great. And then they just take this and shake it up, and then
You're going to
there's
insert a straw, yeah, into the package and drink through the straw.
Okay.
And the straw has a clamp on it so that in between sips they can clamp it closed to prevent the fluid from flowing out.
Okay.
The rehydratable products all require the addition of some amount of water prior to consumption, has the same septum adapter assembly. In this case, they inject the water, they wait for the product to absorb the water, then they're able to cut the package open with scissors and eat out of the package with a fork or a spoon. Typically what they'll do is cut an X across the top. They'll eat out of the center of the X, and the flaps from the remaining material will help hold the rest of the product inside the package while they extract the bite that they're going to eat.
Okay.
You're depending on the surface tension of the wet product to cause it to stick to the package or stick to your utensil.
So there's no turkey carving up there. It's just the scissors, and they cut it open and eat just as that is. So talk to me a little about, so this is what he is doing actually. Right behind us, there's some packaging now. Can you tell me about how long in advance do we typically start to prepare food that's going to be flown into space?
Well, we have to maintain an inventory of our products at all times. And so typically we produce like our thermostabilized products, we'll produce those year round.
Okay.
Because it'll take us an entire year to produce all the different kinds of thermostabilized products that we have. Beverages, we're going to package those usually as needed. And so typically for a ship set, we're going to be, for beverages, we'll start packaging those about 4 or 5 months in advance of the time that the shipment is going to actually go out the door.
Okay.
And rehydratables, usually we try to package those within about a 6 or 8 month period prior to the shipment going out the door.
Okay, great. So this is the packaging, but talk to me a little about the packing. How is this food packed to go up into the International Space Station?
Well, we have a couple of different options for actually the containers that we use to send the food to orbit. One is a collapsible metal food container. Typically we use that when we're sending food on the Progress, because the Progress has slots built into it that hold those containers. Another option that we often use is what we call our bulk overwrap bag. It's really just a large plastic bag that we overwrap the contents of one of those metal containers in.
Okay.
And we're typically using that when we're sending food on the ATV or HTV.
Okay, and these are cargo ships of the different agencies.
Right, yes.
So we have the Progress is
unmanned
the Russian
cargo vehicles, yes.
Right, okay.
Okay, and now with SpaceX, the new commercial cargo carrier,
Right.
we're also using the bulk overwrap bags, the plastic overwrap bags, which I can show you later.
Sure.
And they take those and actually put them inside of the crew transfer bags or the MO2 bags, the different, we have an example of one in there in the lab as well.
Okay.
But they typically take those bulk overwrap bags and stow them inside another container to get them to orbit.
Great. Okay, now, as you know, we've been answering some questions from Twitter that we polled, and thanks to our Twitter followers for sending us these questions. Now, one of the questions, and this kind of talks about the future space food system, so I'd like for you to kind of go on and talk to me a little about what technologies we're exploring for a space food system, because obviously International Space Station is one place, and then there are further destinations that we'd like to go,
Right.
and we need food to sustain us for longer periods of time. One of these questions are, given a true space galley, this comes from Todd Templeman, what's the most useful edible we could grow in an attached greenhouse? Thanks.
Okay, so there's two ways to look at that question. In transit, if you were, say, on your way to Mars on a 6-month mission, which now we know it'll take, with current propulsion, it'll take about 6 months to get there, you could grow some crops during the transit. But typically those would have to be what we call pick and eat crops, meaning something like a cherry tomato that you could grow, you could harvest, and basically all you'd have to do is clean it and eat it. Because in microgravity, you're not really going to be able to do a lot of elaborate processing of crops or elaborate cooking, because without gravity, that gets very, very difficult. So it's not really practical to think about growing wheat in microgravity and then having to mill it into flour. That's not going to work in microgravity.
Sure.
But when you get to the surface of the moon or Mars, and you're on the surface where you have at least partial gravity, you can certainly then begin to think about the possibility of either growing crops to help you recycle your air and water, and then also using them to as part of your food system, or also the possibility of taking like bulk ingredients with you, say like flour, and then doing more elaborate cooking.
So not having our food already prepared, but actually kind of putting ingredients together to
actually
prepare a
doing
dish.
real cooking. Probably you're not going to do that 100% because it does take a lot more crew time. And so in that situation, it's probably going to end up being a mix of prepackaged foods and perhaps stuff that you prepare.
It's kind of like the cooking I do at home.
Right, exactly.
All right, great. Well, thank you. That's a wrap on the food wrap here and how it's wrapped here at NASA, the NASA Space Food Lab, again with Vicki Claris. From our kitchen to yours, happy Thanksgiving.
Since the start of human spaceflight, NASA has worked to improve the taste, texture, and shelf life of food for its crews. NASA food scientists are challenged with developing healthy menus that can meet all of the unique requirements for living and working in an extreme environment. Consider the differences between living on Earth and living in space. Scientists develop foods which will be easier to handle and consume in a microgravity environment. These food products require no refrigeration and provide the nutrition humans need to remain healthy during spaceflight. The Space Food Systems Laboratory includes a test kitchen equipped with sensory testing capabilities, a food processing laboratory, a food packaging laboratory, and an analytical laboratory. It's from these labs that NASA's space food scientists have been instrumental in advancing the variety and quality of foods available for human spaceflight. In the early Apollo days, NASA's space food team developed improvements in freeze-drying technology. That same technology makes it possible for food to remain shelf-stable at ambient temperatures for long periods of time while significantly reducing the weight of the food. NASA has a solid reputation for reaching out to work with industry and academia to develop best practices. NASA collaborated with the Pillsbury Corporation. Together, the two organizations developed the Hazard Analysis and Critical Control Point, or HACCP. The HACCP process is designed to prevent food safety problems during food production rather than in the finished product where they can no longer be corrected. The U.S. Food and Drug Administration has applied HACCP guidelines for the handling of seafood, juice, and dairy products. Many states now require HACCP programs for restaurants and school food service. As we move toward the future, NASA continues to extend an invitation to industry to collaborate and partner. We welcome researchers to work with our team and use our facilities to meet their specific need. Highlighted capabilities include food product development, food preservation technology, including freeze-drying and thermostabilization in pouches, sensory evaluation, shelf life testing, menu planning, and physical testing of packages and materials. NASA's team of space food scientists offer the opportunity to work on a variety of small product development projects. Join us as we continue researching and testing ways to provide healthy and safe food products.
Okay, I am going to get us back to my presentation. Let me share my screen. Okay. All right. So in this presentation, they were talking about different kinds of technology that's going to be necessary for us to go into our future mission for the moon and for Mars. And I mean, for the moon, we're hoping to have boots on the ground 2024, which is just not really far away. So one of the things that comes up, and this is actually kind of falls in line a lot with my background with biomedical engineering, is this idea of nanotechnology. And so I know there's a lot on this screen, but basically the nanotechnology is looking at different ways that they can help food to last longer, whether it's using things, different kinds of polymers that might have different enhanced barriers. They might have heat resistant properties. And then we have to look at the aspect of biodegradability. So we're really trying to get into different areas that are still very new, but some of these have already been tested out. So whether you're looking at trying to have like a liposome structure that would surround the food, it's kind of almost like a fat barrier. But it would be edible and it would actually help the food to last longer. Different kinds of microemulsions, things that would help with the solubility or improve even the vitamins that are bioavailable to the crew, depending on how this nanotechnology structure would be. So there's a lot of advancement that's going on right now with science, and especially in the area of like food chemistry research. And so this is actually helping, in a lot of ways, because we are looking at how is this going to work for us whenever we do have our long duration space missions that might be, 5 years or longer. How are we going to make sure that we have the food and the supplements that we need to have for the crew so that they have good health? So there's a lot of different kinds of things that are going on right now. A lot of kind of designing and food innovation and all kinds of new product development. So if that's something that is interesting to you, you might want to be looking at, food technology engineering and how that is going to be affecting our future, especially for our future different areas of space. So that is about the nanotechnology and advanced technology aspects. So before I get into this and talking about the program that I help out with, there will be another one more video that I'm going to show you that is just from Chris Hadfield. He was actually a commander on one of our missions, and he has a lot of good information. In fact, if you ever want to see different kinds of little experiments and things like that, you can go onto YouTube and look up Chris Hadfield, and he has a lot out there. So.
Let's talk about space food. Vegetables are important for your health, and so today I've chosen dried spinach. To prepare the spinach, you just attach it to the water distributor, choose the right quantity, and push the button. And it's like magic. Dried spinach, and spinach ready to eat.
Okay, so what do I do as far as this culinary challenge goes? So we have students from all over the country that are involved with making some new innovative ideas for different kinds of menus, depending on the theme that we have. And they are working to compete against other teams. Our culinary challenge is a lot different than most culinary challenges that you'd probably find that you may be involved in. Ours is more about understanding the food processing and the microgravity environment. There are certain foods that it's just not really feasible to have up in a microgravity environment, such as crusty bread. We don't want to have all this crusty little bread particles floating around and getting into some of our systems, that we have that are managing the environment that we have on the space station. We also want them to understand the space physiology, what's happening to the body, and why do they have to be so concerned about what they're making. And then once we go through the process, for example, this year, before I get to the process, is actually a healthier comfort food. And a lot of this came about for the theme for this year because of everything that we're dealing with this crazy pandemic time. And so a lot of people are loving the comfort food aspect. And I love comfort food as well, but a lot of times comfort food is very, very high calorie, high fat, high carbs. And so we wanted to try to make something for the crew that is a healthier comfort food. So we have these certain kinds of nutritional guidelines that we have. For example, our calories need to be between 200 and 400. Our fat needs to be 12 grams or less. Our saturated fat, 3 grams or less. Our sodium, 250 milligrams or less. And dietary fiber, 3 grams or more. And sugar, 8 grams or less. And then, of course, the caveat is that it must process well for space flight and for use in microgravity, meaning that we want the food item to be able to, by the way of surface tension, be able to stick to our utensils so that the crew doesn't have little floating particles, going everywhere. So whenever somebody is going to be a part of our program, we first have them do a lot of research, of course, about the microgravity environment and food science at Johnson Space Center. We have several different people that are looking at the recipes and kind of making sure that, yes, you're meeting the requirements that are necessary. Then all across the country, we have these preliminary challenges using the same sensory evaluation sheet that the astronauts use whenever they are testing new food for the JSC Food Lab. Then from there, we choose the top 10. Usually, we have our finalists that go to Space Center Houston, and they will present their food to either astronauts and JSC Food Lab and International Space Station Program Management. This year, we are not able to do that still due to the pandemic. So American Culinary Federation is going to be helping us out with doing some creating of this top 10 foods and doing some judging for us. So that will be very helpful. And then the final winner is based upon not only their entree, but their technical research paper and a video that they make for us. And then the top winner actually gets their food processed for spaceflight through the Johnson Space Center Food Lab. And this is our winners from the past 5 years. And so we've had a spicy Jamaican rice and beans with shrimp, a roasted red pepper risotto, a strawberry rhubarb crisp, a blackberry orange casserole, a harvest hash, and a Moroccan chicken tagine from last year. So I hope that you've learned a little bit about why nutrition is so important for our astronauts and why we go to such extremes to ensure that they have that proper nutrition. Thank you very much for your time today, and I'd be happy to try to answer some questions for you.
Allison, thank you for this tremendous presentation. I think we all learned a lot and grew better insight into NASA and what the HUNCH program is doing in terms of molding food for astronauts in the NASA program. So to the attendees that are on this webinar, we invite you to just ask questions using the Q&A function. We do have some previous questions already sent in, so I'll start with those and kind of mix and match in between of live questions and also what we have before. So there are some questions that Ms. Westover did address in the presentation, so we'll kind of omit some of those. But basically, Ms. Westover, the first thing I think one of the questions is, can the astronauts choose what they wish to eat every day, or is it predetermined?
That's a very good question. Yes, they have a variety of foods that are sent up there, and they can kind of create their own menu when they're up there, but they do have a certain amount of caloric aspects that they have to consider. They have to make sure they're having enough calories to meet all of their exercise demands. such. Also, they do get to have a certain amount of food that is specialized for them. So when we especially have our international partners, they can have the JSC Food Lab actually create the food for them that is, maybe something that is an ethnic food that they really like and they want to have. So there are certain amounts of those that they can have that is separate from the normal menu.
Absolutely. Yeah, that's as an astronaut, I'm sure that it's probably a better feeling that they can pick and choose and have a different, list of foods that they can, choose from. So thank you for that. The next question we have is in talking about intolerances, right? So if there is a gluten-free, vegetarian, or, vegan, or basically just any intolerance for an astronaut, how does NASA and your program specifically handle those intolerances?
So right now, we just have certain foods that are made. Like if we have anybody that has some sensitivities, there are certain physiological aspects that when the astronauts are going through astronaut candidacy, that we have to ensure that they don't have certain diseases that might, like a celiac disease. It would be very difficult for someone with celiac to be able to become an astronaut. There's a lot of health factors that can actually keep you from becoming an astronaut, and it doesn't have anything just to do with, food. It could be your eyesight. It could be if you have high blood pressure, different things like that, that'll keep you from becoming an astronaut candidate. But we do have some crew members that are vegan and they want to stay that way. And so they will have food that enough of that's made for them that they can actually meet all of their caloric needs and their nutrition that way.
Wonderful. And that's got to be beneficial too, as well, having the different options again, as you said. So we have another question here from the live chat. More in particular, you talked about how the food is rehydrated with the water filtration and recycled. Basically a two-pronged question, Ms. Westover. So how is the water specifically recycled on the space station, on the shuttle? And then also, how is that food heated for the astronaut to eat?
Good question. So on the recycling, it's a very huge system that we have on the space station that will take the water that we are getting, whether it's from some of the natural humidity that we might have on station that's collected, the moisture, and then it goes through a process of several different filters, and so we recycle that as well. Also, there is recycling too of their natural excrement, and so it's actually processed very well, very filtered. In fact, it'd probably be cleaner than any of the water that you would normally drink out of just even tap. Sure. So it's very clean. And then as far as heating goes, we can't have microwaves. Of course, we don't have any ovens up there, but we do have a food warmer. So they can actually stick it inside and it just kind of heats it up and gets it a little bit warmer. So if they want it to be warmed up, they can do that.
Wonderful. Thank you for that. That's an interesting perspective in terms of the food warmer. I think everybody here on Earth is so used to ovens and microwaves, as you said, air fryers, even, just the instant reheating process. So it's always, interesting to see how it is heated up, especially from a perspective of gravity, right? So we do have 15 minutes left. So we invite, all questions to be continued throughout this chat. So we have another question, Ms. Westover. So and this is in terms of nutrition, right? So do the vegetables that the astronauts eat in space have the same nutrition as the ones that are dried or the ones that are in a dehydrated or powdered form? In the video, I think that they mentioned that the drink is in powdered form, you add water. So is the nutrition still the same?
Yes, the nutrition is still the same. They try to ensure that they're not doing anything on the processing side that's going to be taking away the critical nutrients, especially since that is such an important factor for the crew.
Wonderful. Wow, it's awesome too. So let's see.
Now, I will mention one thing as far as like the food warmer. We do have a new experiment that has been going up about trying to bake cookies in space. So there's actually an experiment, and they have like a little system. It does not look anything like a normal, like, oven would. And
Right.
they're trying to decide, figure out if they can actually do this, and if they, if we can, and we can actually maybe make it even like a little bit smaller in the future, then it might be something. It's almost along the lines of what I would consider like an easy bake oven.
Sure.
So.
Right, exactly. And kind of to your point, and more of a question for you. So, how often do you see astronauts kind of request those comfort foods versus, some of the more nutrient dense, or the foods you yourself or food scientists would like them to eat versus what they would like to eat or what they're more accustomed to?
Yeah, so I mean, they have, you might have a crew member that just loves M&Ms, okay, and so they're going to have that sent up. But of course, we want to make sure that they're eating the proper nutrition, and they're trained on that. They understand that they need to have, the right foods and eat a very, quality meals. So we of course want to send up things for them that will, be of comfort to them. And that's another reason why this year's theme for the Culinary Challenge is very interesting, because, we do have crew members that are like, hey, I'd love some chicken dumplings. But, I mean, that's normally something that's not going to be a very healthy, it's very good, but not a very good, healthy item. And so, there's several groups that are making a healthier version of the chicken and dumplings. And so I'm sure if something like that gets up to the crew, they would really love that. So there are certain items that they really, really like, and certain food items that they're like, oh yeah, I like that.
Certainly. And kind of just to parlay off your point, Ms. Westover, so we have another question. So was a dish ever designed or conceived or even produced that was not well received by the astronauts, although the food scientists and NASA thought it was a great idea?
That actually happens a lot more than you would think. And that is why at the food lab, what they do is they get the astronauts to come in, and they use that sensory evaluation sheet, the same sheet that we use for our Culinary Challenge. It evaluates things like the taste and the aroma and the texture, things like that. And so a lot of times, when they're testing out a food, it may not have as good reviews as what it would have had, from all before it was processed, basically.
Sure.
And so, so there are times, and that's why they have to go through that. They can't just say, oh, we're going to send this up for you and hope you like it. They actually have to have the astronauts give their approval on this food as well.
Wow, okay. So the astronauts have more of an input in terms of what they also eat as well. So instead of just...
They do.
Great. So we have about 10 minutes left in this tremendous presentation. So please, if you have any other questions that we can squeeze in for Ms. Westover, please send them in. So we do have a question, Ms. Westover. So what are some of the beverages that the astronauts consume? We talked about some of the foods throughout the video. So what are some of the beverages, that they consume?
Oh, they have a lot. They have all kinds of different coffees. They even have like coffee. So if you wanted black coffee, they have a coffee that doesn't have any, cream added in, and it's all in powder form. Okay, and then they'll add the water into it, and then they'll put it in the warmer to get it hot. We have different kinds of teas. We have, lemonades, things like that. We just can't have like carbonated drinks on space station, but you can have milk, and you can have, like an orange drink. It's not probably the same as like your normal orange juice, but it's gonna have the nutritional aspects that would be like the orange juice. So they have quite a variety, actually. Flavored water is actually a huge thing up there for them. They love, water that's infused with some of the orange or some of the lemon or lime. So they do have that up there as well.
Wow. Okay. Well, that's the carbonation. I think that was pretty interesting. Like no pop, no fizz. When you break it out, I'm sure that can cause a multitude of problems. So I'm kind of I'm gonna switch gears here, Ms. Westover. So and be ask a more introspective question. So what is your favorite dish that you've tasted that was designed for astronauts or designed for the space station?
So I know I have tasted their teriyaki chicken, and it was really good. I really enjoyed that. And it's surprising because you think, oh, okay, this food does not look great because of how, because of it being processed, but we've come such a long way in having food taste as, very good, in fact. So it's kind of funny. And even like some of our dishes, that have gone to space station, from this challenge. For example, the strawberry rhubarb crisp. Okay, so the food lab, we really liked that, but we were trying to figure out how are we going to process this. And they processed it. They kind of did it in the thermostabilized form. So the crispy part wasn't really there anymore, but it almost was like an oatmeal kind of form. And we actually all got to taste it too before it went up, and it was very good. And so instead of it being kind of almost dessert-like, it was really more of like, we could have this for breakfast, because of the way it was processed. But yeah, the food up there is actually not too bad.
Wonderful. That sounds good. I'm sure got a rhubarb crisp recipe or something that we would like to try as well. So we have a couple more minutes, and I apologize to the attendees. We're getting a lot of questions. This is wonderful. So I'll try to get as many in for Ms. Westover as possible. So they want to know, Ms. Westover, what is the maximum temperature of the food warmer?
So it's really kind of like as if you were warming it up in your oven. So around maybe 200, 250, I believe, is what it can heat up to. So because it's not going to have like a baking function, it's just a warming function.
Okay. And has there ever been a food that astronauts didn't like, but they just had to eat anyway?
No, I mean, okay, so there's definitely, with a variety of food that's up there, you're going to have some crew members that are like, I don't like, for example, Chris Hadfield making that spinach. Okay. You might have some crew members that say, well, I don't want that spinach, but they don't have to eat it. They have other things that they can kind of create their plate with. They can choose their meat, they can choose their veggie, they can choose their carb, that they want to have. And so not everybody has to have the same, food for their plate, and they don't actually get to have a plate that they put their food on. They just get to kind of choose. I'm going to choose these 3 items, and they're going to be my dinner. And so then they open them up, like Ms. Claris was showing about how they do like an X across the top of it, and then they'll eat it out of there. So it's very different than how we normally eat down here.
Right. Oh, I'm sure of it. Yes. Without trying to eat something without a plate, or even utensils. So thank you for that. And so we have another question. I'll choose 2 more before the presentation's over. So how would somebody who would like to become a research specialist or a food scientist dealing with these certain types of foods and practicalities develop new and improved foods? So how would they get into this field of, a research scientist or developer?
Yeah, so I mean, there's a lot of different programs across the country that have food science. I know Texas A&M University is huge on that. They have that, but I know there's other ones across the country. Even those that are in biochemistry or chemistry or biology. I mean, if you start interning, there's a lot of different kinds of internships that go on at NASA, and you can just go to nasa.gov and go look up internships. And you might find some that are there for, the food lab. There's a lot of different ways. I mean, if you get some different kinds of intern experience, whether it's at NASA or like at, one of the food companies, even if you're you're not in food science directly, but you're in other kinds of sciences, that's the good way to kind of get your foot in the door and have that experience that you can put on your resume for NASA.
So experience, especially in the scientific field. Wonderful. And kind of parlaying into that, the next question and the final question, Ms. Westover, how can students get involved with the Culinary Challenge, the HUNCH Culinary Challenge?
They can definitely email me, talk to their teacher, and have their teacher say they're interested. We have a statement of work form that they can fill out. On my last slide, I'm hoping that maybe you'll share that, my presentation out with students. But on my last slide, it has my email, and it also has our culinary website, which is just HUNCH, HUNCH, culinary.com. And they can go there and fill out there's a place for interest, and they can fill out some information there and send that to me. So yes, we are definitely welcoming of anyone that wants to participate, and always looking for new teams.
Ms. Westover, it's been a pleasure. Thank you so much for your time and insight with NASA. And I think I'm extremely enlightened and eager, kind of want to try that rhubarb crisp and see how that can turn out. But thank you for your time. We really appreciate it. At this time, I would like to pass it over to Jackie for our final remarks.
Thank you.
Well, a huge virtual round of applause as we thank Allie and NASA HUNCH for such an informative presentation. We very much appreciate you taking the time to share your insights. And of course, we're very proud of the ACF's partnership with NASA HUNCH. Thank you all for tuning in today, and a special thank you to Massachusetts ProStart for joining us and collaborating with us today. We hope that you'll join us on an upcoming ACF ChefsForum webinar, and we'll also have another collaborative webinar that we hope you can make it March 17th for Chefs Go Green, Reducing Food Waste in Your Kitchen, presented by ACF as part of the National Restaurant Association Show Live. So for more inspiration, for more information, for culinary news, to register for upcoming webinars, please check out our website, wearechefs.com. On behalf of the ACF National Office, thank you all. Thank you to ACF Young Chefs Club. And once again, thank you to Allie and NASA HUNCH for the opportunity to learn. We appreciate it, and we look forward to seeing you soon. Thank you.
Thank you.
Thank you.